The technology of the telephone business is evolving so rapidly that no single organization, however large it might be or however talented it might be, can expect to cover the full range and gamut of technologies that are important to meeting the needs of our customers. And we recognized early on that while there was much that we would do right here at Science and Technology, that there was much knowledge and much valuable information we could get by working closely with universities. The process basically started by researchers at Nynex's Science and Technology based upon their contacts and their knowledge of the academic field, looking for universities that already had a focused effort in closely related areas. The next process involved establishing a direct relationship with the professors at the universities doing this work and seeking out and determining if there was an area of mutual interest. And it was that kind of a process that led us to focus on schools like MIT, NYU, and Lowell. And as a result of the fact that we were working individually with all three, it soon became apparent to the team that by bringing these universities together, we could be even more effective. And I think that was one of the hidden but very pleasant surprises and I think benefits that came from this relationship.
The University of Lowell is building an environment for analyzing the content and use of mixed media telecommunication sessions. The project leverages Lowell's previous collaborations with industrial partners in engineering and manufacturing.
The value of industrial partnerships is it provides us with a platform for evaluating case studies based on real needs.
In the first year of the project, researchers built a test bed for mixed media communications involving 3 different sites connected by optical fiber. The first site is the factory floor. At this site, there's a malfunctioning machine that needs to be repaired. The problem is reported to an engineer in another part of the factory. To solve the problem, the engineer needs to consult with a service representative from the company that designed the malfunctioning equipment. Together, they build a multimedia bug report. A live video image of the malfunctioning part is transmitted to the service representative. He compares the video image with a CAD drawing of the part and discovers the problem. He then communicates his findings to the engineer and prepares an engineering change order.
Sometimes the solution to a problem cannot be seen until various media forms, CAD, video, audio, are brought together and looked at together in a form that before was not possible.
It's important for us to emphasize that the technology that we have used to create these demonstrations is actual working software and hardware. The communications is live using a video switch and fiber optic communications. The workstation software does allow mixed media document transfer between workstations in a live fashion.
Researchers at the 3 project locations are sharing their findings in the hope of improving our understanding of how mixed media telecommunication systems should be developed and implemented.
The technology is capable of doing a lot more, but it also is becoming increasingly more complex. And if we continue on the train which says the technology is what it is and the human is going to have to find a way to interface with it, well, we're going to find that the technology is greatly underutilized. With respect to these 3 schools, one of the things that interested us in particular was that all 3 were working in the area of multimedia communications. As a result of the diversity of ideas that are coming to us, and as a result of the interactions that take place, I think that we are in a much better position to be able to provide our customers with the multimedia communications that I think is going to be an important part of how many of them conduct their business in the latter portion of the 1990s.